So we've worked with rational functions in the past, and now what the goal for this section 5.6 is, we want to be able to graph them. Now we're not going to be able to graph them perfectly, but we're going to be able to get a rough sketch of what a rational function might look like. It's similar to what we did with our polynomial functions, but rational functions look different, and there are a lot of pieces to look at, but we're just going to take it one step at a time and look at each piece, and then at the end we'll put it all together so we can sketch a graph. Okay, the first thing we're going to talk about though is using arrow notation. So we have two of our toolkit functions here. We have the 1 over x function and the 1 over x squared function. So let's see how much room I have. No room. Okay, so we'll talk about the vertical asymptotes and the horizontal asymptotes first. So in my first graph, I have a vertical asymptote right here. You can see that this function's approaching negative infinity as it gets closer to the y-axis. And then on the other side, it's approaching positive infinity as it approaches the y-axis. And so that would be a vertical asymptote. We also have a vertical asymptote here on the 1 over x squared, the reciprocal squared function. Those would be vertical asymptotes. Okay, so vertical asymptotes, we usually make a dotted line and they're going up and down. We're going to describe them as x equals some number. Okay, so those will represent our vertical asymptotes. We represent it as an equation. Horizontal asymptotes, so there's a horizontal asymptote right here on our 1 over x function, or our reciprocal function. And there's the same horizontal asymptote on the 1 over x squared, or the reciprocal squared function. So horizontal asymptotes go like this, and they'll be written as y equals some number. So in this case, it's y equals 0 for both of them. And the vertical asymptotes were actually x equals 0 on both of those. Okay. Now we're going to talk about the arrow notation. So let's see, where can I write this? You'll notice that our graph on our first one here, so I'll do the 1 over x function. It's approaching, well, let's go this way first. As it approaches negative infinity, it approaches the x-axis, right? So the output is approaching 0. So as x approaches negative infinity, f of x is approaching 0. And we've done stuff like that before. Okay. Now let's go the other side over here as x is approaching positive infinity. Well, as x is approaching positive infinity, f of x is still approaching 0. Okay? So those are still true. You may have suspected those. But we have kind of a different thing happening when x approaches 0. Okay, so something's happening here. And it makes a difference which side we're coming from. As we're coming from this side, as x is approaching 0 from the left, we're going off toward negative infinity. But as we're coming from this side, as x is approaching as x is approaching 0 from the right, it's going up toward positive infinity. And we have a way to note that. So we say as x approaches 0 from the left. So that's what that little superscript of a negative sign means. It means you're coming from the left-hand side. As x approaches 0 from the left, f of x is approaching negative infinity. But as x approaches 0 from the right, so you're going to use a little positive sign or plus sign up there for the superscript as we're approaching 0 from the right, so that would be this case, then f of x is approaching positive infinity. Okay? So that's maybe a new notation that we have, and hopefully that works for you. Okay. So now let's do a similar thing for the other function. the reciprocal squared function, well, it looks like as x approaches negative infinity, f of x is approaching 0. And as x approaches a positive infinity, f of x approaches 0. And as x approaches 0 from the left, f of x is approaching infinity. And as x approaches 0 from the right, f of x is also approaching infinity. Okay, so that would be all the statements there. Now, you might be wondering, well, if I'm approaching negative infinity from underneath, that looks different than if I'm approaching positive infinity from above. But we don't denote a difference in above or below. Okay, so they're just approaching the x-axis, 0 in both cases. Okay? So I think that's it for the arrow notation.